Hello everyone, welcome to TriRights, the new era of learning. Myself Sheikh Abdul Rafiq, I am your data science trainer. Now let's begin to the concept. Today's, our- today's in our section, I introduce data science statics correlations, right? In previous section, we have discussed about static variance, standard deviation, and coefficient of variations, right? Now we are discussing static correlation, right? Correlation measures the relationship between the two variables. It measures the relations in between two variables, right? It's predict the value, it's convert input to output, which means f of x to x, right? We can also say function uses the relationship between two variables for the prediction. Okay, in this we have similarly we can see in static correlation three conditions to find the relationship between the two variables. One is in that we measure 1, 0, minus 1, right? For 1, we predict as perfect linear relationship. For 0, no relationship. For minus 1, we predict as perfect negative linearship, right? Not unperfect, it is a perfect negative linear relationship because it, it doesn't it doesn't consider a value into minus. It considers the value into perfect negative. So we called as perfect negative linear relationships, right? Now see the relations for what we see 1, 0, minus 1, right? Perfect linear relationship between the variables. Okay. Now see the 0, no relationship in between the variables. Perfect negative relationship between the variables, right? Minus 1. Okay. Now let me take example of a perfect linear relationship, right? Coefficient of correlation, right, equal to 1. Now we find the correlation of 1, what it measures, right? In see the graph, we want to print this kind of output. It has such as perfect perfect correlation. Okay, as you can call perfect linear relationship too, right? Now let us wait. Take the graph. I will explain in simple terms. Let's take a graph. Nice to take the graph. Okay, let's consider as three graphs we have. Okay, in that this is 1 and this is 0 and this is minus 1, right? The three relation we have to predict. Now see, in perfect relation, the graph will move linearly towards right. That is, what do you mean by linear relationship? Linear relationship is nothing but linear function is nothing but one independent value and one dependent value, right? Its linear function has a straight line, right? Straight line. So in the straight line, we have to measure this scatter function. We use scatter kind. See dots. This is the perfect relation between the two values, right? This is x and this is y. Okay, between the two variables, we have find the perfect relationship as moving as according to the linear function. The line is moving to according to the linear function, right? In in 0, there is no linear function includes. There is no relation between the two values, which was x and y, because it's only show you where the value is targeted. There we see the scattered dots, right? In it, we can see any inline between or in connection to the variables. No, it's randomly spread. Overall data will spread into the randomly. There's no connection in between the variables, right? So we call as zero relationship. Now in negative minus one, for the minus one scatter, it represent line has opposite to the linear function, right? It represent opposite angle. We can say. Now see, in it same has one. So that's we call because it's not moving into the negative value, negative into depth down to negative. It's just bending the angle and turning the angle into opposite side of the linear function. So we call perfect negative. So this is perfect negative. This is perfect negative relationship, and this is no relationship, zero we call it as. This is called perfect linear relationship, right? Both are 1 and minus 1, or the both are the perfect linear relationships. Just it's in minus 1 it turns the angle of the linear function. Okay, now for now we are writing the code for 1, right. Let take a variable has statistics. So okay, we are discussing with correlation, right. Now let us we want to, for the graph we want to import matplotlib, right? Import matplotlib dot dot has plt. Yeah, another function we want to import for reading the data frame, we use import pandas. Okay, import pandas has pd, right? Now, uh, yesterday we created a data frame, right? For that, take the data frame. No, did not data frame. We create a, we want to read import it now. So read CVSC, direct import the file. What the data we had measured, health data science, right? This is the data we have created. Now take the data, take the health data dot CSV, right? Give the headers 0 and separate with them by column. Okay. Now put into a variable has health data, right? Now, now we for health data we do plotting, right? For x value we give as, for x value from the health data we take as average pulse. See here what is saying for to find the profit relationship from the graph, average pulse and calorie burnage, right? So for the two variables we take as one as x is average pulse and y as calorie burnage. Now ux variable has average function and y equal to calorie burnage. No. So in this same we do code. If previously we also done this code. Little bit changes. We are changing the structure of the line. Yeah, not overall code we are changing. Just we are changing the structure. In the previous code we use kind has line, right? To in linear function, right? For now instead of line we use scatter to represent the graph in dots. Okay. Now show PLT. In this we don't need to show y lim, y max, min max. We don't need. Just we want to represent showing the perfect linear relationship, not the in between the angle. No. Okay. Now see the graph. Actually, what it represents. See how exactly the data represent has the perfect relationship, perfect linear relationship for the correlation, right? It is a perfect relationship. It's line. In previous, it is a line. In that, we are showing the correlation of dots, right? You take x from start with 80 and y from start with 240, where the exact value starts. From that, it takes the direction, right? Okay. Now, same as we want to find the minus. So not minus, no relationship between. Now we talk about the no relation. Now we talk about the one relationship between the two values, right? Now we put the highlight marks on it, right, in between the relation of one, right? Now we do code for zero variables. There is no variable, for zero variables. Now we want to do it. Same code, but little bit change here we're doing. We just changing the x value. That's it. Nothing to cha cha want to change in anything in that. Only we want change the average pulse into any unordered structured data. We want to mention unordered structured data by removing the structured data, right? Same code we want to copy the same code. Just change the x variable, right? Here I am highlighting and commenting the code. You can understand and you can write it. Now now watch the graph. Now let's see the data. Which data is some unordered? Let's see. Yeah, we can take duration, right? Because duration starts from 30 and calorie burn starts from 240. It has more difference in between the range. Now see, okay, it is perfect to take as a zero relationship. Copy the code and take it as a x value, right? Take it as x value. Now we can see the zero relationship. See, in this we see the data how likely spreaded dot. Any relation in between the data of x and y for the duration and the calories burned? No, it is unordered because it is unordered data, right? Now see the another. Let's take the hours work. Now let's take the hours of work, right? Now just take now I give x value. In case y x value, I give the calories per the calorie. I change the y value to see the both are equal or unordered data. Let us wait. See, still the data is unordered. No relations. We can say has no relation in the data. So this data, like this data, we called as zero, no relationship linear function, right? There is no relation in between the hours work or duration, or we can call it x-axis and y-axis, right? Okay. We I hope you understand what is the perfect linear relationship and no linear relationship. Now let's take another data. Now what we want to see? Now we want to check the minus. See the output like here this now. So for this minus one. So for this zero relationship data like this we represent the data, right? What is measuring? Here we plotted max pulse against the duration from the full health data set. As you can see, there is no linear relationship between the two variables. It means the data training section does not lead to the higher max pulse, right? Now, I want to represent this graph. It is nothing but it's called as a perfect negative relationship, right? We didn't call as unperfect or no relationship as a, we just call it for perfect, not unperfect, perfect negative linear relationship. Okay, I hope you understand. Now here we want to now keep the highlight the data. Now here we want to measure the data. Now see. Now in the data, let's see once check the data. Now check the data. In this we have any unordered, any minus. See data is unordered. These two average pulse or calories is perfect relationship. Max pulse also a perfect relationship because it following the order. 95, 85. Here also increase over. Oh, okay. Max pulse and calorie burnage are not in order because 130, 140 duplicates is present. So it's also duplicate is there 60, 60, 60. So it is also No problem. I have already considered as a data. Let's I created another file as I changed the average pulse by 1020. Like this also we can present, or like this we can create by our own data structure. First we will take data like this, and then I will create the function like by own function, right? Same has same data. Now data dot data. Just I want to change. Let's copy the code. Has same code we are entering. There is nothing change. Mm, I want to change first. I want to change the here data store data underscore data. That's my file path name, right? Right. Now forward work hours and duration. Now I want to change as perfect relationship here. Average pulse. I change the data for average pulse, right? Copy it and paste here average pulse. And for calorie burnage, it is the it is perfect for the turning the angle of the linear function. Right. Now see the data. Now check. Now see how data is directly connected to lower value connects with higher value, lower value connects with higher value. Direct trigger is the zero. It is opposite. It is I think 45 degrees angle. It is 90 degrees. It will bit bend like 45 degrees. It's showing reflects to the 45 degrees and opposite angle of linear function. Linear line nothing. Linear line nothing but straight line no? Like this straight. So it opposite direction angle. So we call as minus one perfect linear negative relationship, right? Instead of this we can take like this we can take like this too, highlighting this path and this part too for now matplotlib. I also imported my matplotlib. Now instead of this I want to create a data for finding the negative relationship, so that I create another health data. This is I create another health data, like you can say I create another data frame. Health data equal to pd dot reach. No, I'm creating the data frame. So in between I want to take okay, let's take change the value negative now. Negative correlation, we want to finding the correlation now. For negative, let us print negative correlationship for the data. For this I'm creating a table. Again first class we all discussed how to create a data frame, right? I'm taking a random number to represent the negative linear relationship. Let us take any data, like I said data 1. I said data 1. I'm showing the difference from the data 1 and data 2 to represent the negative value, right? Now it's take we take 10, 9, it taking reverse 8, 7, 6, 5, 4, 3, 2, 1. Right? We take the data up to 1. Mm, here I create another for there has data 2. For data 2 I can assign up to highest value. The trigger is it's a 10 value for the upcoming one value, or 10 it triggers the highest among value. So up to I consider has 2 from 200 I will take 200, 200, 220, 240, 260, 280, sorry 300. Now it's take 320, 360, 340, 380. Right now it's check that how much we count 1, 2, 2, 3, 4, 5. Right, 5, and here to here we take data is correct now. Right, for we created data like this. For we created negative core. For negative core we apply plot. Right, for negative code we apply the now take the negative frame pd dot data frame. I consider a variable name has the same data name, so no a big issue. We can see many kind of codes like this. It doesn't get error because this is variable and this is another variable. It consider like in memory. Okay. Okay. Now put the negative core for plot it x value IQ x value has data 1. IQ x value has data 1 and y value has data 2. And I said no, I want to, in this we use to find a relation we use kind scatter. Okay, now it's done. Now show the graph. For showing we use plt show, right? Plt show in matplotlib is nothing but in python we use a print statement for printing the data. In mysql we use select query to print the data like that. In javascript we use to console.log off. So that kind, so like that kind in the matplotlib we use to represent what the data we want to show. It like it use like a print statement. Plt dot show it use like a print statement. Now print it. See how the in with the range is different lah. It almost similar to the native language because it's bending the line. Here the data get changed. Right here the data get where 2 or 3 has changed. So for the find the perfect data, I take the variable from 240. Okay, I add removing the 200 because it's not taking as perfect relationship in between the range. So I take up to 400. Now I want now check once. Now check once. No, it's still taking like that. It's awkward, man. Why didn't I think it's just a little bit changes getting in here. So wait, let's check it. 220 to for 220. It's represented from 220 line. So 10 is getting reverse. 10 8 10 9 8 7 6 5 4 3 2 1 right. 220 240 260 280 300 320 360 340. Oh yeah, yeah. Here we change. Here the difference. Here we got mistake. That's why its graph literally changed. Sorry guys. I did a numbering mistake here. Now we can say as a negative perfect linear relationship. Now see how the actual data is representing the float, right? Like this, we can find the what is actual correlation, what is actual 1 0, what is perfectly linear relationship, what is no relationship, and what kind of is negative relationship. Like this we use in core relationship. Okay, I hope you understand well guys. Thank you for this section.